Okay, so this is Pask Makes, the YouTube channel Pask Makes. This is his, generally his design. He sells plans for this. This is holds a mini router, and the idea is that this is a loose mortise machine, much like the Festool, the green monster that's like $1,000. So the idea is we put this together, and that this is going to move back and forth, vibrate back and forth. Well, not vibrate. You have to move it yourself, right? And then you can plunge it, and it's on rails, right? It's got a little spring in there, if you can see that little compression spring, and it doesn't use a drawer glides like some of the other versions of this or designs on this type of machine. And it moves back and forth. But here's the problem that I had. One thing is I bought these. These are little kind of right angle things. You can get them from Amazon. I'm just looking for them. I'll try to find them. Post comments on them. And in Pask Makes, Pask Makes, what he does is he uses something like this. He uses a little channel, and then he cuts it, and then cuts a little tiny slot in it. And this slot is bigger, and there's actually a little play in that, and I think that's one of the reasons he did that. So I might go ahead and build it fully to his directions. But part of the problem is that once you get this in here, you think, okay, well, this is naturally going to be centered, right? And the problem is it's not quite. How do you find the center? So you have a cylinder, and generally your router bit is going to be at the center there. Yes, that's true. But there's a couple different things you have to do. So the problem is this might not be aligned vertically this way, up and down, up and down. And so that's what this little thing is. This is to make sure that it stays at the same height, and so that it is, hopefully, it's going to be parallel to the base here, but more importantly, it's really parallel to this and perpendicular to its front, where it sits against the wood that you're going to drive in. So you're driving in the wood like this way, and you'll see these marks here on the front of this, and I'll get to those in a bit. This is me drawing lines. I draw lines on the top, and then it aligns with this. You can see that line that I cut into this. And you align it, and you're looking up and down. And part of the problem is that there's a little parallax there. There's a half inch of material, you can see. So that lets you, you can kind of see that. It kind of is not super accurate. So a better way to do this would be move this glass plate down to the bottom and actually cut a groove with something like a router here. And cut a little where this would go, so this is closer to the line that you draw. So that would really help. Then that would be right next to it. In fact, you flip the whole thing, so the cut in the plexi is on the underside. I'd have to go back and check Pask plans and see if that's what he recommended. I don't think that's what he recommended. And there's some sandpaper underneath there, and that helps grip it when you're plunging it. So part of the problem is what I found out when I first put this together is I'm making this and I'm moving it back and forth, and where did the wood go? I had a sample here. One second. Okay, so here's a sample I was doing, and you can see I'm doing the same thing. I'm drawing lines, I'm drawing center lines, but then I'm also drawing edge lines, right? And I'm drawing edge lines of where I expect it to be. And when I was doing this, like, I did these lines first. These are kind of like just pressed forward. So I'm checking the alignment of it to make sure the line is correct to where the center is. And the problem is I kept getting these variants. Like, I would do it over here. Oh, it's a little bit to the right. And so I'd move it, and then it would be a little to the left. I'm like, okay, well, that's normal. And then I get straight on. And then I go and I'm like, okay, that one's, wait a minute, that one's a little back to the right. And then this is all the way to the left. So I was doing the lines and checking the lines, and I couldn't find center. So the problem is, which is kind of a deep problem, how do you find center on a cylinder, and to make sure the back to the front and to the line, which is past your pivot point, which is under here, how are these all aligned? So part of the problem is you want to be able to make sure that when you do, I want to do an inch mortise, right? So I can do an inch tenon and maybe have a little play in there, you know, maybe like a millimeter or something like that if I wanted, or less, ideally, that you fit that into. You want to make sure that's completely accurate and centered, because if you then try to line up the other piece of wood and it's to the left on one side and then to the right on the other, or it would be to the left on one piece of wood and then to the left on the other, and then they don't line up, you're actually then kind of possibly moving the joint, and then the lines that you draw don't meet up, and that would be, of course, very bad. So this is very small, you can have to admit, this is like a millimeter maybe to one side, a millimeter to the other side, straight on, but then this is like 2 millimeters. So how do you find the center? So that's the problem, and I'm sorry this is a long video explaining it. So what I did is that I went through a couple different stages here. I took this, right? I took this, and then I actually balanced a rod. Here's my rod. So I found the center of this long rod. This is actually the rods that I use to make the carriage on the moving. They're back here on this. Makes it a little heavy. If I would have done it again, I would have found tubing. But in some ways it's good. So it's a very long rod compared to this, and it balances at a certain center point. So I marked the center point, and then what I could do is that I could mark the top, the very top of this cylinder. And these lines are experimentations. And what I actually found why these lines vary, like back and forth, is even though this is a long rod and it's heavy and it's on the top, even then when I put it on the top of this, it could vary like 1 millimeter either way. And you would say, well, you could just see where does it still balance on the top of the cylinder, or the circle in this case. If you can imagine a line on top of the circle, where does it balance? That should be just 1 point, but it actually is a little range. It's a very, very small range there. And you could say that I'll just do the outside of the range and the inside of the range and then find the center and mark it. Yes. But here's the issue. The issue is, how do you know that that's the top? That's the top, and that it is actually balanced. So there's a couple different things. You could have something that's balanced, but that's not the center. It's the top of the point. Well, anyway, I think I might have to illustrate this if I have had to write it out. So anyway, I basically took a level, a very small, I have a little line level, and the line level, I realized it's kind of weighted on one side, and I was worried that when I put the level on top, I could get this level, and that's going to be the most center of the points of these kind of range of points that I can balance this on. But it was it's a light level, and I wasn't sure if it was affecting or not. So I got a bigger level that's more balanced, and I marked the center of that level, and I put the level on the rod. So I can make sure that this is, and right now you can maybe see, maybe it's apparent, maybe it's not, but it's balanced on there. I just put it on there. I didn't really worry about it too much. But I don't think it's actually level. So it's not at the very apex top of the cylinder. This would be very good, easy to do in a diagram, but not really easy to do in life. So the whole problem was how to do that. So now I have these lines. So I take this rod and I have it parallel to the ground, so to speak, so it's balanced. And I also made sure that the bottom of this carriage was also level as well. So this table's level, the floor is level, this is level, and it's leveled this way, and it's leveled this way. And then I put the rod on it, and I make sure the rod is then level, and then I draw the lines. So that is actually the center top of this. And you notice it's a little bit off from what the kind of machined was. So it might be that this is turned a bit. So this is a very long video. I apologize. So I basically put a line here and a line there. And by balancing the rod and saying, okay, this is the very top of this, and it's probably not going to do it now because I don't have the level on top. And you can see it's kind of tilting a little bit. This is a little high. Maybe you can see that. This is a little high. it's going to be impossible to tell. It's moving. It's like a little toy. So I have that line and that line, right? And then how do I make sure it's aligned in the front? And that's what we're going for. We want to have a straightest line possible. Because if we go in and, like I said, if we don't have this all connected, then they're not going to meet. Anyway, that's the point. Okay, let me show another thing. Okay, so I asked my wife, and very intelligently, I was like, how do I know what the top center edge of this is? I want a straight line from the back to the front, and then I want to be able to mark this guide, so I always have a straight laser level. My laser level is not working. I think it's broken. But you know what comes with a laser level, or a line, straight line, is my chop saw. So I can take, I'm going to do this with one hand. I'm going to line up the lines that are on there, and the laser level gets a little more accurate as you go down, and we can get, sorry, I'm doing this with one hand. So basically it's a little bit off there. We're gonna need to fix that. So this level hits this line and back. You can't tell, it's kind of hard to tell with the, and hits all the way up here, and you tell this is a little bit off. But the weird thing is, to make matters worse, excuse me, that was loud. This is just getting straight. So this is straight. So I've tried to jam this against there, and I had to move this back a little bit because I was having too much play in this. And I moved this back here. And then I measured to make sure that this back edge is parallel with this back edge. And that's all to say that what I found is trying to tweak this, you could basically tweak it by adjusting these and back to make them center. And that would get more of a center line when you come it down. So basically, before, I didn't know, I could measure from the edges of this and find out where these are placed, right? But what seemed like more accurate was to basically draw the lines on the board over there and then shove it in and then see how far away it was from it, from the true center of that just going forward. And then I would loosen the one side. So, you know, if I want to go to the right, I have to loosen the left so I can move it over and then move over this one just a bit too. And then do that incrementally. And that's how you really hone it in, right? But all that's going to do is find your exact center. Then you're going to mark it. Then you're basically going to have to do the whole thing again. Now that you have your true center, you're going to move this out a bit, both sides, and measure it. And I would say with a caliper, measure it out the same distance from each, from the center mark that you've made. So you put a center mark here, and then you're going to move this out until you get like your size of the dominoes you want. I think they're generally around 20 millimeters, some are 19, 20 millimeters, and there's 22 and there's 24 millimeters. And I think generally I'm probably going to think that I want an inch, 10 in, maybe an inch and a quarter, inch and a half. So I'm going to do each of those little quarter-inch increments so I can take stock and make stock strips and then make my own tenons. So that's the next step. But that's the long process that I did to try to figure out, okay, what is the center and how do I make a center line on this and make sure that it's accurate to the front, right? And that's why I'm going to have to move this. And I think I'm going to put it underneath, but let me show you how this, well, I'm going to do another video and show you how this works. This has already been too long. It's been 14 minutes. You probably don't want to hear that. Anyway, so that's what all these lines are. And that's how you tune this Pask Makes loose tenon machine on. Oh, one more thing about this, and I'll probably say this in another video if I do another video, is he suggested you use this dryer vent stuff. So the dryer, and what he used is the plastic like tubing, and so that's what I had to get because this is more springy and it wants to be springy out, right? And the dryer vent stuff, it wants to be compressed, right? And so I would have to make another ring here and then attach the ring to the back of this and then have another clamp. to do that. And the problem with this is then its dust is coming everywhere when you do the zerg, 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 zerg. Anyway, too long video. Talk to you later. Bye. Everyone, enjoy.